Now that we've introduced ourselves to function notation, let's just continue to practice it and get used to what it's saying, what it's not saying, and how to do it. So we'll take a look at a lot of different situations and apply function notation to the situation. So I've got a function here called f of x. It's given by this parabola, and I'm asking you for f of 0. So again, this is a very precise way of asking you for the input when it's the output when I let the input be 0. We're putting 0 into the function f. So I'm going to come up to the function, and wherever I see a x, I'm going to replace it with 0. And so doing the evaluation, we end up with -8. So you can kind of say it this way: when x is equal to 0, y is -8. You can write it as an ordered pair, 0, -8, or functionally speaking, we're saying that f of 0 is -8. So when my input's 0, my output's -8. So however you want to say that, those are all good ways of saying what's the action that's happening here. Input 0, the output is -8. You guys probably recognize that as a y-intercept is essentially what we found. Next example, we have f of 3. So how do we do this? Well, first we have to recognize the fact that I'm letting x equal 3. So we got to find y. What's the output of the function f when I put a 3 in it? So coming to the function, again, I'll just simply replace all my x's with 3. Do an evaluation, and I believe we get 7 here. So again, as a ordered pair, we're talking 3, 7. In function talk, we're saying f of 3 is 7, or you can literally say x is 3, y equals 7. That's essentially what's happening again in that example. Changing things up a little bit, here we have f of x equals to 0. So again, be very careful about the notation. F of x, this is a fancy way of saying y is 0. So we have to basically find what input can I put into this function and get 0. So we're going to come back up to the function and replace that f of x with 0. And in this case, we have a polynomial equation. We know we solve that by factoring. And so when I factor it, I believe that factors as x plus 4, x minus 2. The 0 factor property kicks in. So one of these two is 0. Subtract 4, we get x equals -4. Add 2, we get x equals 2. So when x is -4, y is 0. Or when x is 2, y is 0. Or as an ordered pair, we can write our answers like that. All right? Or functionally speaking, f of 2 is 0, f of -4 is 0. Any of these answers I'm satisfied with. You're clearly indicating who's who and what you found. Sound good? All right, so one other example, we've got, sorry about that, again, f of x is equal to 2. So y equals 2. So we got to, again, find the input that creates that output. So going through some stuff here, we're basically going to come to our function and replace that f of x with 2. And now we have an equation to solve. In this case, we would subtract 2 from both sides, get 0 is x squared minus 2x, and I believe that's minus 10. So again, we have another parabola, another polynomial equation. I believe x minus 5, x plus 2. Uh-oh, we're having a little trouble here. Okay, so right now, right, since we can't factor that, right, a good answer would be no solution. But I'm going to put a back burner on this. I'm going to put this in highlights and all kinds of good stuff there. There actually is a solution to this, and we'll take a look at this later on in chapter 11. So kind of setting the stage there. So we need more math to finish this problem off, but hopefully, again, for what we're learning now, what does this mean? It means this. We're going to try to solve it. We ran out of, this doesn't factor as far as we're concerned. Some of you probably remember the quadratic formula. We'll be using that, all right, or completing the square to do it. So there is a solution to this. It's just that right now we lack the algebra to do it. But functionally, we know what we were supposed to do. We just ran out of algebra. So let's keep moving forward. That happens from time to time, okay? Now I've got a new function called g. and I'm asking you to find g of 7. Again, we're putting 7 into g. X is 7. So I'm going to go to my function, and I'm going to replace the x with 7. And absolute value of 7 is 7. We get negative 4. So x is 7, y is negative 4, or you can use the ordered pair, or you can say functionally, that's what I have. So all those are good answers to describe input, output. Here we're letting x equal to negative 4 and putting it into the function. So I'm going to go to it and replace that x with negative 4. Absolute value is positive 4. Take that subtraction, we get negative 1. So my ordered pair is negative 4, negative 1, right? Or you can say functionally g of negative 4 is negative 1, right? Or just say it, right? X is negative 4, y is negative 1. Make sure we're really describing x and y. So hopefully you guys are getting the hang of it. In the next example, I've got g of x equals to 0. Again, be careful, right? This 0 is what g of x is equal to. This is saying y equals 0, not x, y. So we have an output, we need to find the input. So go back to our function, and here's something a little new to us. I don't think we've ever solved an absolute value equation before. So here's our first sneak peek at it. What I'll do first is subtract 3 from both sides, and we basically get negative absolute value. Sorry about that. Negative absolute value of x equals negative 3. If I divide both sides by negative 1, we get absolute value is 3. Since the absolute value is how far we are from 0, there's two potential answers. Negative 3 and 3, right? Those are both values that create an output of 3. And you can kind of even see that happening. If I put a 3 in here, 3 take away 3 is 0. If I put a negative 3 in there, 3 take away the absolute value of negative 3 would be 0. So there's two answers. So there's actually two ordered pairs on the graph. Negative 3 of 0 and 3, 0 would be our ordered pairs if we were graphing. Okay, so kind of our first glimpse at an absolute value equation. In the next one, g of x is equal to negative 2. All right, so again, be careful. I'm not letting x equal to negative 2. The notation is saying y is negative 2. So setting my equation equal to negative 2, we're going to try to solve it. I would subtract 3 from both sides. This would be negative 5 equals the negative absolute value. If I divide both sides by negative 1, let me kind of flip it around, we get x equals 5. Again, whose distance is 5 units away from 0? Well, negative 5 is a candidate, and so is 5. Alrighty, so kind of a different thing there. It's more of a 150 topic, but the idea of, I'm letting an output equal something, find x, and we figured out how to find a new equation. Graphically speaking, again, we're talking about two ordered pairs. Alright, so that sounds good. That's how we use the function notation. We'll do some more examples and some kind of weirder cases in the next video. I'll see you guys then.